So students, in this video there are a few new things that I want to teach you. Few new, a little new, few new theorems, I would say, and those are theorem number 1. It will be this thing: limit x tends to 0, sin x by x is equal to 1. That means what the question says is, if you directly substitute 0 here, it will be sin x by 0, which is dividing by 0, or even sin of x, that is sin of 0, so 0 by 0, sin of 0 is 0 only, so 0 by 0, which is indeterminate. It is impossible, I mean indeterminate, you cannot determine the value, you get it. So it is not possible to do that, so we cannot do direct substitution. But what does the question say? So is it a lie that so 0 by 0 is not equal to 1, but the thing says 0 by 0 is equal to 1? No, it is not. What this thing, that is why this limit makes a lot of difference. What this thing says is, as x approaches more and more closer to 0, the sin x function, or the sin of x by x function, sin x by x, this fraction approaches more and more and more closer to 1. You get it? It does not reach the point, it does not reach the point 1. It may not reach the point 1, but it approaches more and more and more closer to the point 1. So at the point 1 there is a break, but when you look from this side and when you look from this side, it approaches more and more closer to 1. That is what the question says. That is what the whole chapter of limits, whole topic of limits says. Okay, so this is one theorem. Another theorem is, limit x tends to 0, 1 minus cos of x divided by x is equal to 0. That is, when x approaches more and more closer to 0, this fraction here approaches more and more closer to 0. Now that is the second theorem. And the third theorem is, limit x tends to a. Now this n could be any integer. It could be any integer. It could be any number. N could be any number, any real number. And when x approaches more and more and more closer to a is some constant which we do not know right now. It could be anything. I'm read in a general format. When x approaches more and more and more closer to a, this fraction approaches more and more closer to n into a to the power n minus 1. So when x becomes more and more like a, this fraction becomes more and more like n to the power a n minus 1. That is what this thing says. Now I know that it might look a little difficult to study. I mean, with practice you will actually get it. But without even doing any practice, I mean, if you want to know how you get it, I'm ready to show it. So if for the students who are really interested in knowing how we all get this, how is this true, how is this true, people who want proofs, give me a message and I will send you the video showing how you get it. Because not everyone will be interested in not how you get it. Some people this is fine, I guess, but for people who are really interested in knowing how you get it, give me a message and I'll show you how you get it. Okay, so, and it's simple proofs. There's not much difficulty in the proofs. The proofs are this proof is kind of a little bit of a headache but other two proofs are actually kind of easy. Okay, so keep this in mind, store this in your mind and in your book, and let us solve few more questions. Okay, so next question is, limit x tends to 0, tan of x divided by x. So how do we solve that? So we know that now, okay, before that we know what tan x is. Tan is sine by cos. So let us write that. Limit x tends to 0, sine of x divided by cos of x into x. Right, this is, so sine by cos is tan, you know, right? So now what do we see here? Just now we studied limit x tends to 0, sin x by x is 1. So using that we can say that limit x is tending to approaching to 0, you can see that. So we can say this value sin x by x, this value we can say that it approaches to 1. So knowing that much, what we can do is, let us write so this thing is equal to, write it down. So I'm applying the limit, so I'm not until the variable is still there, you should always write this thing. Okay, till the variable is gone, you should always write that thing. So x tends to 0, it will be sin x by x approaches 1, so 1 divided by, not every time sin x by x approaches 1. Okay, sin x by x approaches 1 only when the x value approaches 0. That also you should remember. Only when x approaches 0, sin x by x approaches 1. So it will be, okay, so continuing, sin x by x approaches 1 and divided by cos of x. Now you know that cos, now directly put the value, or shortcut method. So 1 by cos of 0, and it will be 1 by 1, and cos of 0 is 1, so it is 1. So you see that the whole value approached 1. You get it? So limit x tends to 0, tan x by x. If anyone asks you what value does it approach when x tends to 0, you can say it approaches 1. Now, okay, now let us go to another question. Yeah, limit x tends to 0, x into sec of x. Again, you know, let us just apply what we studied, because and let us see. Solving this implies, or you know, if implies here, this is equal to limit x tends to 0, x into sec of x. Then I can write it as x divided by cos of x, because 1 by cos is sec. Now what can I do? Okay, doesn't look like it approaches anywhere, because yeah. So anyways, let me write. So when I'm applying the value, let me see what happens. When I'm putting the value of 0, shortcut method, it will be 0 by cos of 0, which is 0 by 1, and that is acceptable, you know, quite acceptable. 0 by 1 is 0. It is fine. I mean, when x approaches 0, the answer approaches also 0. Very decent fraction. Okay, that is good enough. So let us move on to our another question, and that is ax plus x cos x divided by b sin x, and of course x tends to 0, and so how can we solve this? Pretty interesting. Okay, let's see what we can do. We see an x here and we see an x here, so we can take x common. So this is equal to limit, x tends to 0, taking x common, a plus cos of x whole divided by b into sin of x. It's pretty nice. Oh, I'm complimenting myself. Anyways, this thing I can write it as is equal to, I can rearrange the terms. It will be limit x tends to 0, a plus cos of x. I'm sorry for this horrible handwriting. I mean, this is because I'm not writing in a book and I'm not writing with a pen. That is why this handwriting comes like this. Okay, anyways, so it is divided by b into x divided by sine of x. Oh, by the way, sine of x, you should not write sine. S is not capital, S is small letter. Same applies for cos also. So sine of x. Okay, so I'm just rearranging this. I wrote, these terms, rearrange it. A plus cos x into x divided by b into sin x. Now, why did I do this? In the homework that I asked you to do, I had asked you to see, that limit is applicable for products. You can when there is a multiplication, you can duplicate the limit. So that is, I'll also write this as limit x tends to 0, a plus cos x whole divided by b, and I can also again apply the limit, because this is multiplication. I can apply the limit f of x g of x is equal to limit f of x into limit g of x. You saw that, right, in the book. So x tends to 0, x by sine of x. Now guys, look at this fraction. Let me rub off a little bit so that you can enjoy what you see. Okay, now when you look at this, what do you see? This is, we saw that limit x tends to 0, sin x by x is, when x approaches 0, sin x by x becomes 1. So if sin x by x is 1, x by sin x is also 1. Why? Because 1 is equal to 1 by 1 only. So however way you do, you invert 1, or you put however way you invert 1, it becomes 1. So sin x by x is also approaches 1, and x by sin x also approaches 1. So this whole value I can say that it approaches 1. So what do you get? Now you get limit x tends to 0, a plus cos of x whole divided by b into 1. So I'm not writing that. So now what do we get? This thing I can write it as is equal to, I'll put the value of x now, shortcut method. So it is a plus cos of 0, and you all know what is cos of 0, divided by b. So it is a plus cos of 0, that is 1, divided by b. So it is a plus 1 by b, and there you get the answer. One more thing. Okay, so you see that when x tends to 0, ax plus x cos x divided by b sin x, it approaches a plus 1 divided by b. So you see how we got this question. Now let us go on to see one more question. If I'm right, it's only one more question. And that is using the third theorem. Limit x tends to 0, x to the power 15 minus 1 whole divided by x to the power 10 minus 1. So how to do this? So we know that, or I know that, limit x tends to a, x to the power n minus a to the power n divided by x minus a is equal to n to the power a minus 1. So if I can get this in this format, I know what it approaches. See? So we will try to do that. Because if I directly apply the value here, I will get divided by 0, and that is not a good value to reach. So in that case, let me take this off, and now let's try to do. This will be, so what I'm going to do is I'm going to divide the numerator and the denominator by dividing numerator. Don't write in your book dividing, this is only in this video that I'm doing. Dividing numerator and denominator by x minus 1. Okay, because in that theorem I need the denominator x minus 1 or x minus a, and in this question the a is 1, so x minus 1. So I'm dividing both numerator and the denominator by x minus 1, and when I do that, I get x to the, okay, I should write limit x to the power 0, x to the power 15 minus 1 whole divided by x minus 1, this divided by x to the power 10 minus 1 x to the power 10 minus 1 whole divided by x minus 1. Now you know that in that thing which I asked you to read, limit of f of x divided by g of x is equal to limit of f of x divided by limit of g of x. Using the same thing, I can write this as, good thing I can rub in the screen, so just divided by limit x tends to 0. I can do that also. Remember to put the brackets so you won't get confused and I also won't get confused. Now after this, what I can do, I can see that using this, it is almost in this thing. So what does it say? X to the power n minus a, this is x to the power n minus a to the power n. See, 1, because 1 to the power 15 is also 15, right? Sorry, 1 to the power 15 is also 1 only. 1 to the power anything is 1. So I can imagine there's a 15 here. So in that case, x to the power 15 minus a to the power 15, a is 1. So let me use a different color so that you won't get confused. Okay, so a is 1 and n is 15. So you see x to the power n minus a to the power n whole divided by x minus a. Here also x to the power n minus a to the power n, 1 is to 10, 1 is to 10 is also 1, then x minus a, x minus 1. So you see that both the things are in this format. So what does it approach? It approaches to n into a to the power n minus 1. So to get some space, I am taking this off. So it approaches to n into a to the power n minus 1. So it is equal to n. N is 15 here. Approaches 15 into a, and a is 1. So 1 to the power n minus 1, that is 15 minus 1. Okay, divided by, and what does this, okay, what is this thing? Let me take this off. And this approaches to 10, n is 10 here, into a is 1, a to the power n minus 1, 10 minus 1, that is 9. Perfect. Now let's see where it goes. Let us solve that, and we see that this approaches 15 into 1 to the power anything. 1 to the power anything is 1. So that is 15 minus 10 into 1 to the power anything, that is 10 itself, 1 itself. So 15 not minus, sorry, 15 divided by 10. So 15 divided by 10, and 15 divided by 10 is that is 3 divided by 2. 5 into 3 is 15, 5 into 2 is 10, so 3 divided by 2. And there you get the answer. So you see how we use the topic limit, how we use the concept of limits and how useful it is. See, actually you will learn another use of it in the next year. God willing, in the next year, 12th, you will learn another use of it. But that we will, wait for next year. So for now, I will stop limits here. You can practice a little more from the book. And from the next class, we will move on to, let it be a suspense. We'll move on to something else. Okay, so for now, bye-bye.